Hi students, as a part of corrosion unit, today I am going to discuss another corrosion controlling method and what is the first corrosion controlling method which is widely used for the corrosion of any of the metal. I have explained in the previous video, which was the cathodic protection, right? And in this particular video I am going to discuss another corrosion controlling method. However, none of the method can avoid or control or prevent the 100% corrosion of any of the metal. Keep this in the mind. And why? Already I have explained clearly in the previous video, which was made on cathodic protection. Now we are going to discuss about surface coatings. Surface coatings. That is, how by surface coatings we are going to control the corrosion of the metals. And these surface coatings are basically classified into two types. The one is organic coatings and the second one is inorganic coatings. And organic coatings examples are the paints. However, I am not going to discuss about the paints because it is not a part of the syllabus, right? So on the demand on the paints, if you ask to make the video on the paints, I will make the video on the paints, but it is not important from the examination point of view. Now, coming to inorganic coatings. So, inorganic coatings are usually the metals. So, since inorganic coatings are usually the metals, these inorganic coatings are also called as metallic coatings. That is, in the inorganic coatings, we are going to coat the metals on the surface of the base metal. What is the base metal? Clearly, I have explained in the video which I have made on cathodic protection. And the metals are inorganic substances. And since the inorganic substances are going to be coated on the surface of the base metal in order to avoid or protect or control the corrosion of the base metal, this particular method is called as inorganic coating. This particular method is called as inorganic coating or metallic coating. So inorganic coatings or the metallic coatings can be done on the surface of the base metal, making use of the following methods. The one is hot dipping, second one is metal cladding, third one is electroplating, fourth one is electroless plating, and another one is also that cementation. But among these five, I am going to discuss only about three. The one is hot dipping, second one is metal cladding, third one is what is the third one, friends? Third one is the electroless plating. I am not going to discuss about the electroplating and the cementation because they are not a part of your syllabus. But do remember that these are the five methods by which we can coat the metal on the surface of the base metal in order to avoid or prevent or control the corrosion of the base metal. So, the first method is the hot dipping. Now, hot dipping method is applicable to the metals. It is applicable to the metals having higher melting point than the coating metal. It is applicable to the metals having higher melting point than the coating metal. Because in the hot dipping method, what we are going to do is we are going to immerse or dip the base metal into the hot molten coating metal. Now, if the melting point of the base metal is less than the coating metal, definitely it will melt. So that is the reason the melting point of the base metal should be greater than the melting point of the coating metal. So that is, it is applicable to the metals having higher melting point than the coating metal. And hot dipping process are generally carried out by two ways. The one is galvanization, and the second one is tinning. Galvanization and tinning. And in this particular video, I am going to explain you about how the galvanization is being done, which is one of the inorganic or metallic coating, which comes under the category of surface coating, which prevents or controls or avoid the corrosion of the metals, corrosion of the base metals. First, let us say what is galvanization, and galvanization is also called as galvanizing. Now, first let us see what exactly is the galvanization or galvanizing. It is a process of coating the zinc metal on the surface of the base metal. The process of coating the zinc metal on the surface of the base metal in order to avoid the corrosion or control or prevent the corrosion of the base metal. Now, don't be confused, friends. The process of coating the zinc metal is called as galvanization or galvanizing, whereas the process of coating the zinc powder on the surface of the base metal is chemiurgizing. Anyhow, it is not there in your syllabus. Chemiurgizing. Zinc metal, that is galvanization. Zinc powder is chemiurgizing. So the following figure illustrate the galvanization or galvanizing process. That is how we can coat the zinc metal on the surface of the base metal in order to control its corrosion. Usually during the galvanization or the galvanizing, the base metal is the steel sheet or iron sheet. Now, before I explain what is the first process to be done on the iron sheet or the steel sheet, which is the base metal, students, whenever the stubborn stains are sticking to the apparatus in the chemical laboratory, what you will do in order to remove those stubborn stains which have been accumulated firmly to the apparatus. In order to remove the stubborn stains, what you will do? You will add some acid to the apparatus. Now, as acid is very strong, it removes all the stains which are accumulated on the surface of the apparatus. Now, by discarding that acid, which comprise of the impurities, which comprise of the stubborn impurities, we can make the apparatus free of the stubborn impurities or stubborn stains. So, in the similar fashion, here the base metal is either the iron article or iron sheet or the steel sheet. Now, since the base metal is the iron sheet or the steel sheet, definitely it will be a part of the environment. Since it is a part of the environment, definitely it will be associated with so many impurities. So many impurities like dust, dirt, scale, greasy material, rust. Now, there is a need to ensure the removal of all the impurities before going to dip this base metal into the hot molten coating metal, that is a zinc metal. So, for the removal of all that nonsense stuff which is already accumulated on the surface of the base metal, what we have to do is we have to pass the iron sheet or steel sheet into the bath containing dilute sulfuric acid, which is maintained at 60 to 90 degrees centigrade. And we have to pickle it. Pickling, right? So, during pickling process, whatever the impurities like dirt, dust, scales, greasy materials and the rust which have been already accumulated on the surface of the base metal will peel off. Once it peel off, whatever the base metal which is taken out from the bath of dilute sulfuric acid is free of all the impurities. It is free of all the nonsense stuff which have been already accumulated on the surface of the base metal, but it is full of sulfuric acid molecules. It is full of sulfuric acid molecules. Since it is full of sulfuric acid molecules, definitely we need to remove those sulfuric acid molecules from the surface of the base metal. From the surface of the base metal. What is the reason for removal of the sulfuric acid from the surface of the base metal, students? Because in this particular galvanization or galvanizing, which is one of the surface coating technique or method of corroding, that is method of corrosion controlling, we are using the zinc as the coating metal. and zinc is present above the hydrogen in the electrochemical series. Since it is present above the hydrogen in the electrochemical series, the zinc, which is the coating metal in this particular galvanization or galvanizing, will dissolve in the acid, resulting in the formation of the toxic compounds. So, we need to remove the sulfuric acid molecules which have been accumulated on the surface of the base metal, which is iron or steel sheet, whenever it was immersed in the dilute sulfuric acid, which was maintained at 60 to 90 degrees centigrade, in order to remove the nonsense impurities or nonsense stuffs which have been accumulated on the surface of the base metal. Now, in order to remove the sulfuric acid molecules, what we need to do is we have to immerse in the washing bath. We have to immerse the iron or the steel sheet which have been removed from the dilute sulfuric acid, which is comprised of the sulfuric acid molecules, which is free of all the nonsense stuff which have been accumulated earlier, should be passed into the washing bath, and this washing bath is comprised of the water. Under the influence of water, we have to pickle it. So whenever we pickle it, whatever the sulfuric acid molecules which have been accumulated on the surface of the base metal will peel off. But here, do remember that by washing with the water, we cannot remove the 100% of sulfuric acid molecules from the surface of the iron metal. Why? Because iron metal is also above the hydrogen in the electrochemical series. Since it is also above the hydrogen in the electrochemical series, even it can undergo dissolution. That is, 10% of sulfuric acid molecules will dissolve inside the iron sheet or steel sheet. Now, whatever the iron or steel sheet which is coming out, which is the base metal from the washing bath comprised of the water, is free of 90% sulfuric acid molecules. 90% sulfuric acid molecules containing 10% of sulfuric acid molecules and moisture, because it is coming out from the water. It comprises the moisture. And under the moist conditions, what happens already you know. Under the moist conditions, wet or electrochemical corrosion is possible. So definitely we have to remove the moisture which have been settled on the surface of the base metal which has been immersed in the washing bath, in order to remove the dilute sulfuric acid molecules. For that, what we need to do is, whatever the water molecules which have been accumulated on the surface of the base metal should be passed into the drying chamber, and in the drying chamber, hot air is being maintained, and under the influence of the hot air, 100 degrees centigrade of temperature is being maintained in this drying chamber. And what is the boiling point of the water, student? The boiling point of the water is 100 degrees centigrade, and since in the case of the drying chamber, because of the hot air, that particular 100 degrees centigrade of temperature is being maintained. Under the influence of that 100 degrees centigrade, the water reaches its boiling point and gets evaporated from the drying chamber. Now, whatever the base metal, that is iron or steel sheet, which is coming out from the drying chamber, is free of impurities. In the first process, is free of 90% sulfuric acid, second process, and free of moisture, third process, drying chamber. Now, this particular base metal which is free of impurities, 90% of sulfuric acid molecules and moisture should be passed into, or should be immersed or dip into the chamber containing hot molten zinc, which is maintained at 425 to 430 degrees centigrade. 425 to 430 degrees centigrade, and this hot molten zinc, which is maintained at 425 to 430 degrees centigrade, is more susceptible to undergo oxidation, because oxidation is nothing but the corrosion, and the corrosion is directly proportional to temperature. Since the corrosion is directly proportional to the temperature, So definitely, as the coating metal, which is the zinc, is associated with the high temperature, definitely it will undergo oxidation. So in order to prevent the oxidation of the hot molten zinc, which is being maintained at 425 to 430 degrees centigrade, what we need to do is we have to cover the chamber containing hot molten zinc, which is maintained at 425 to 430 degrees centigrade, with ammonium chloride flux. This ammonium chloride flux will avoid the oxidation of hot molten zinc. Right? Now, whatever the iron or steel sheet which is coming out from the chamber comprised of the hot molten zinc now contains the layer of the coating metal, that is zinc. That is zinc. Now let us say that this is the base metal. What is the base metal, students? Iron or steel. And now the coating metal has been accumulated on the surface of the base metal. Coating metal has been accumulated on the surface of the base metal. Coating metal has been accumulated. Right. Coating metal of what? Zinc. Coating metal of zinc has been accumulated on the surface of the base metal. But there is no guarantee that whatever the coating metal, which is the zinc, which has been accumulated on the surface of the iron sheet or the steel sheet, is forming the uniform layer on the surface of the steel or iron sheet. So non-uniformity layer will be formed on the surface of the base metal. Non-uniform layer of the coating metal, which is zinc, takes place on the surface of the base metal. Now, what is responsible? What is responsible for the non-uniformity of the coating metal, which is zinc, on the surface of the base metal, which is iron or steel sheet? Non-uniformity of coating metal on the surface of the base metal is due to the excess accumulation of the coating metal, which is zinc. At some place, excess accumulation of zinc takes place. So due to the excess accumulation of the zinc, the layer of the coating metal, which is zinc, which is going to be formed on the surface of the base metal, will not form uniformly. It will form non-uniform. Now, what is responsible for the non-uniform layer of the zinc metal on the surface of the iron or the steel sheet? Excess amount of the zinc. Now, once we remove the excess amount of the zinc, then we will get uniform layer. Once we remove the excess amount of the zinc, we will get the uniform layer. We will get the uniform layer of zinc. This is red color represent zinc. Red color represent zinc. Uniform layer. So in order to remove the excess amount of the zinc, which is responsible for the non-uniform layer on the surface of the base metal, which is iron or the steel sheet, what we need to do is, with the help of the rollers, we have to roll it. We have to roll the galvanized sheet. Now the galvanized sheet has been formed because on the surface of the iron sheet, the zinc has been coated, but excess amount of the zinc has been coated. Now from the galvanized sheet, we need to peel off the excess amount of the zinc, which is responsible for non-uniformity of the coating metal on the surface of the base metal, which is iron or steel sheet. Right. Now, uniform layer of the zinc metal, which is the coating metal, has been formed on the surface of the base metal, which is either the iron or the steel sheet. Uniform layer has been formed. But there is no guarantee that, let us say that this is the base metal. Now this is the coating metal. Now there is no guarantee that this coating metal is binding firmly with the coating metal, binding firmly with the base metal. There is no guarantee. So there is a need to ensure the strong bond between the coating metal and the base metal. So in order to ensure the strong adhesion, strong sticking, strong bonding between the coating metal and the base metal, what we need to do is we have to pass the galvanized sheet. Galvanized sheet means the base metal is iron on which the zinc has been coated. That is the galvanized sheet, and that galvanized sheet, in order to ensure the 100% adhesion or sticking or binding of the coating metal with the base metal, we have to pass the galvanized sheet into the annealing chamber where higher temperatures are being maintained. Under the influence of the higher temperatures, whatever the coating metal which has been formed as a layer on the surface of the base metal binds firmly with the base metal. Finally, we have to cool and we have to collect the galvanized sheets. And these galvanized sheets cannot be used for making the kitchen utensils in which the food is preserved. Because why the galvanized sheets cannot be used for making the kitchen utensils in which the food is preserved, students? Because in the galvanized sheets, the coating metal is the zinc, and the zinc will undergo dissolution in the sulfuric acid. And here, by means of the second process, that is washing the iron sheet, in order to remove the 100% of sulfuric acid molecules from the surface of the base metal, we are not removing the 100% of sulfuric acid because the iron is also above the hydrogen in the electrochemical series. Now what happens? 10% of sulfuric acid molecules have been already entered inside the iron. Now iron contains 10% of the sulfuric acid molecules. Now on this, zinc has been coated. Now the zinc is more anodic when compared to the iron, because iron value is minus 0.44, zinc value is minus 0.76. So since it is more anodic when compared to the iron, now whatever the sulfuric acid molecules which are present inside the iron sheet, under the influence of those sulfuric acid molecules, even this coating metal, that is zinc, will undergo dissolution, resulting in the formation of toxic compounds. Now, based upon that, we can say that the galvanized sheets are toxic in nature because the coating metal zinc is undergoing the dissolution in the sulfuric acid molecules which have been left during the washing of the base metal, which is iron or steel sheet, in the washing bath with the water. That is the reason the galvanized sheets are toxic in nature. So since they are toxic in nature, we cannot make the kitchen utensils making use of the galvanized sheet in which the food is going to be preserved. So that is the reason galvanized sheets are exclusively used as the sheets for roofing, right? And these galvanized sheets can be used for making of the nuts, bolts, rivets, etc. But it cannot be used. These galvanized sheets cannot be used for making the kitchen utensils in which the food is preserved. So since the galvanized sheets cannot be used for making the kitchen utensils in which the food is preserved, definitely we have to use the other sheets by which we can make the kitchen utensils in which the food is preserved. That is tin plated sheets. And tin plated sheets can be obtained making use of the tinning process, so which is the next process involved in hot dipping, or it comes under the category of the hot dipping. I hope you understood this video, that is the galvanization or the galvanizing, so which is important, right? So please do comment if you really like the video. Thank you.